It was muted. We're good now. Did you hear any of that? Okay. I was going to assure you that it was amazing. All right. So for those of us that work in the public sector, that actually raises some particular challenges of how do we actually get the data in the cloud? How do we get compute near the data? All those nice things that people want. There's challenges on the funding side of things, security mandates, infrastructure, some outdated models out there that where people are just, there's policies in place where people are just expecting that you have a static IP address that will live for the life of your application or whatnot. So today we have three speakers who are going to be speaking about their experiences in bringing compute and data to the cloud in government environments. And after those three speakers talk, we're going to have a bit of a panel Q&A if anyone here is having particular challenges or wondering about things in their own experiences that these guys might have some insight into. So yes, without further ado, we'll move on to our first speaker. So Andrew Pawlowski is the cloud practice lead at Element 84. He has been working on cloud migrations for NASA for several years now, both on the NGAP program and also at Goddard Space Flight Center. So Andrew.
Can you hear me okay from here? Cool. So my talk is specifically about the government cybersecurity directives for the cloud. And really, I want to contextualize it that according to the government's guidance, cybersecurity is simple. They put out this publication. It's called NIST 800-53. Every government cybersecurity professional has this on their bedstand. And it establishes a bunch of different control groups. And these for your IT system are requirements for how people access the system and how what is stored, what is audited, how data is encrypted, among a bunch of other things. It's really a process and a framework to secure the cybersecurity system. And it maps really well to corporate data centers. This is where you have a static footprint. You buy hardware once every 3 years, maybe 5. You deploy code on top of it, but for the most part, things are stable, they don't change, they have the same physical hardware it runs upon. And it also has vertical operational needs. And what that means is from the code that's deployed all the way down to the fiber and the power that powers these servers, there's an operational mandate up and down that stack. And really the model there is that there are slow changes to infrastructure and rapid deployment of code. You're only changing your infrastructure on the scale of years. Now, of course, in the cloud, you have kind of the other end of that spectrum. And at first, it does map well. You have maybe a virtual machine in EC2 instance, which is just like a machine running on-prem. But from there, you might scale out and introduce a load balancer. This is a managed service that you don't maintain yourself. You might offload data to some static service like S3. You might introduce a CDN like CloudFront. And eventually, you might find that you don't need virtual machines altogether, and you move to a serverless stack, which is API Gateway and Lambda. And what these services do isn't really important, but what is notable is that when you get to a point like this, you're not managing any of that infrastructure. You're managing your code, but everything else is handled elsewhere. And so now we're not just talking about deploying software on a static set of infrastructure. We're talking about deploying everything from the code all the way down to the infrastructure itself. And these changes happen quickly. Like oftentimes, like within a single dev ticket, you can introduce a new service that has to be secured. And it's further complicated by the fact that the services you're using within AWS or the cloud in general, here I'm talking about AWS, but this is true whether you're using Google or Azure, they're secured in different ways. So if you're running in a virtual private cloud, their software-defined networking layer, you can secure things with like a network ACL or a security group. If you're running outside of a VPC, maybe an S3 bucket, that's locked down with policies, which is a different mechanism than the NACL. And then finally, if you're interacting with the infrastructure, you have IAM permissions. But the complication there is that every service has different actions, and the granularity there does not map across all of the cloud. It's at the service level. And so the fact that within a single dev ticket, you can introduce changes to your infrastructure, and the fact that there's complexity of securing that in the cloud you find that well-equipped organizations still have problems with security. And these are security issues that should be stopped by a well-defined security framework like NIST 800-53. But because of that speed and complexity, it doesn't work. So we need to figure out a way to take those static on-prem controls and map it to the cloud model. And what we do at the GCC and what NGAP is also doing is focusing on some core features that extend that NIST 800-53 framework. And that's adaptive monitoring, well-defined verification criteria, and then an easy to invoke change process. And really the goal there is to expect and support rapid changes because the cloud's not going anywhere. We need to make sure we can support that. So adaptive and rapid monitoring. What this focuses on is what questions you want to ask at a given time. This is like who is logged into any server within our system. This is what network paths are being used within a system. It's also who has access and how. These kind of questions that you want to at any given point answer, you need to make sure you have a service that can do that. So two services we use are at the GCC are Guard Duty and Systems Manager and Security Hub. And so what these do is they give you a real-time view into your system. And you could say, okay, is anybody talking to a blacklist of IPs? Are any of our Lambda functions or EC2 instances interacting with a botnet, or are they mining Bitcoin or something they shouldn't be doing? You need to be able to have a service that could pick this up quickly. Verification criteria. This is how can you certify that a system is secure? Again, a single dev ticket maybe introduces a new service. How can you know that service is being used securely? And the way we do this is in tandem with your infrastructure code and your application code, is you also build those checks. So here, this is AWS config. Really the idea here is you have something that can sweep your system and see if they're meeting the policies that you set. If you don't have this, you cannot certify that the code that's being run is behaving the way that it needs to within your system. And then most importantly is change management. This is how do you support new features or services or patterns within the cloud. This is an old slide. This is actually about 5 years old now. But if you can imagine, if you can extrapolate this graph, this is the amount of features and services launched by AWS each year. It is crazy fast. It is not feasible for a single group to vet all of these actions and vet all of these services. You need to have a framework in place for how you handle a new service being added, because then you can build a queue and you can build a backlog and you can handle them based on priority. And really these three things should address the fact that work in the cloud isn't slowing down, it's accelerating. I think everybody in here has seen that just over the past 2 years, 5 years, 7 years. And we need to update our compliance methodologies to support it. That's it.
Okay, next up we have Ben Williams. Ben Williams is a cloud operations architect for the NASA Earth Data Cloud. He served as a technical lead for several cloud and big data analytics projects within the federal space, with a particular focus on infrastructure modernization and cybersecurity.
Thank you, Patrick. See what I can do about finding the presentation in some sort of efficient manner. Wrong one. A little sneak preview of our anchor leg here. Great. Good morning. Again, my name is Ben Williams, talking about cloud governance at scale. And what we really mean here is how do we manage as the use of the cloud expands, as the number of tenants and accounts expands dramatically, how do we keep up with it from a managerial administrative standpoint? Inside the Earth Data Cloud environment, we've adopted a well-architected cloud governance solution, largely from one of our vendors that we have a strong partnership with in Stratus, who's developed kind of pillars of a well-architected solution. And we try to model some of the administrative components of our architecture and compliance requirements and business processes into these pillars and help use them to communicate to our end users and tenants. So today for our agenda, we'll be talking a little bit about the goals of the Earth Data Cloud environment, some of the cloud specific challenges that we run into operating inside of AWS specifically at scale, some of the methods that we use to address those challenges, and then looking forward, some of the items on our roadmap or things that we're expecting. So first off, with goals, this is my dog Sully, who really likes toys, but really hates water. So this was followed by a series of intense barking and disappointment on his part. So in the cloud, one of our first goals of Earth Data Cloud is to have a large multi-tenant ecosystem. So we have an ecosystem that's very diverse from data scientists, software developers, and our end user community who all support different missions and organizations. It's an incredibly diverse environment that we are trying to govern. The types of applications that are supported run the gamut. Some are traditional servers and virtual machines. Some are entirely serverless based, object storage and distribution applications, all running within our same multi-tenant ecosystem. All of our various missions have different application life cycles. Some of them are continuous delivery sorts of applications that are pushing code out to their environments daily. Some are more on a more traditional quarterly or biannual release process. And we have to cater to different levels of expertise as far as operating in the cloud. We have managers and executives who need to see the reports and understand what's going on in the ecosystem from a budgeting perspective, as well as software developers who are very experienced inside of AWS, and interns who may only have worked in a isolated laptop environment are now exposed to the immense power of the operating and developing in the cloud. We have to maintain security assurances. So the Earth Data Cloud has an obligation to maintain a baseline of security for the entire ecosystem and for our NASA sponsors. So there's a ATO process that we have to go through. We're held to the NIST 853 standard. FedRAMP is certainly a portion of what we're involved in, agency, specifically NASA, specific mandates, and then industry best practices to make sure that we are doing the best that we can. And one of the things that we, one of the challenges that we run into there is, while there are many commercial off-the-shelf solutions for traditional on-premises sorts of infrastructures, there's less of that in the cloud. So a number of the security challenges that we run into are rejiggering things that had already existed in an on-prem environment, where a COTS solution may not be available. Additionally, we have budget assurances. We're operating in the federal space, so we are held to the Anti-Deficiency Act, which says whatever we budgeted for, we cannot go over, lest there be unexpected or undesirable consequences. And we also want to minimize unneeded cost in this environment. So in the cloud world's pay-as-you-go model versus traditional IT procurement, the power of purchasing any particular increment of cloud resources is handed over to the developers. Sometimes it's handed over to those interns, rather than going through the traditional process where there's an exceptional amount of vetting and approvals that have to go through before dollars are spent. That power is given to everyone with access to an account. And then last, and probably most important from a data science community, is that we want to give our tenants, our software developers, complete autonomy. We don't want to, as system administrators, be in the way of them innovating and finding better solutions to their problems. We're not data scientists from the Earth Data Cloud development and operations team. We're cloud guys. We know that the best solutions that the data science community are going to achieve is when we as cloud experts get out of the way of the data scientists and make sure that they are able to build whatever they see fit. That ends up having challenges with the other three in so much as we do have to meet budget assurances and security assurances. And so we've adopted a pattern of providing guardrails, kind of bumper rails against going too far out of line from a security or budget standpoint. So some of the challenges that we see in the cloud, and this is a particularly challenging cloud, cumulonimbus cloud. Cost. In the pay-as-you-go model, cost becomes a big issue. Where in the traditional IT procurement process, there's a budgeting up front, everything's paid for up front. If you're developing new code, you're developing it on a server or networking infrastructure that was paid for up front. So the only ongoing variable is power and cooling. Where in the cloud, you're not worrying about power and cooling, but you're paying for each element of code or element of cloud resources that you're running. And so we have to develop some sort of assurance to make sure that we don't go over budget. We have a couple of those sorts of controls implemented in the Earth Data Cloud environment, which are essentially firewalls for cost instead of traffic. We have components that freeze the spending of particular accounts. This is effectively eliminating the ability to provision new cloud resources. So whatever daily rate had been established for spend can no longer increase. We also have a concept of a circuit breaker. So if the freeze spending rate, the daily spend is continuing at that point, circuit breaker comes in to actually shut down cost-consuming resources in the cloud in order to make sure that you don't overrun your budget. Additionally, and area of sensitivity for the data science community is our data egress controls, where in most of the cloud providers, you're being charged per gigabyte of data egress that's going out of your system. And there's various models that the commercial industry is able to adopt in order to offset those egress costs, but in our community, we're not at liberty to charge our end users like Netflix charges for their downloads. And so we have to have controls about how we monitor and assure that our egress costs don't go over budget, to which Nathan Clark will be speaking more about. And additionally, we want to detect these sorts of costly behaviors that maybe are purely legitimate, but maybe are nefarious or may be just lazy development practices. And so we use various, what I would call intrusion detection, except at a cost standpoint. And some of those are AWS provided services in AWS Guard Duty, which monitors for all sorts of potentially nefarious or, again, lazy development practices. And AWS Soft Limits is another example that helps prevent our application owners from spinning up resources that are particularly expensive or inadvertently auto-scaling a cluster to 100 nodes or something like that. So we have some of those soft limits and a number of other controls in order to help avoid overrunning our cost. Boundary protections is another area where our cloud practices differ from our on-prem practices. In so much as on-prem, at some layer, there's one pipe in and one pipe out of your data center. It's your ISP, your router. You have a single point of control, or maybe some easily enumerated places of ingress and egress to your data center. So you can put your firewalls, you can put your IDPS systems close to that control point, and you know that you're covering all your traffic. We don't have that luxury in the cloud. We do if we're limiting ourselves to Amazon Virtual Private Cloud, VPC environments, where you're essentially having a dedicated network in the cloud. You can establish one way in and one way out. But as soon as you move beyond the VPC, as soon as you move into some of the real value add services that the cloud provides, you lose that single point of ingress and egress. Serverless applications or services like AWS Lambda, S3, DynamoDB, all of these exist outside of the traditional networking environment. But still, we want to have some sort of boundary protection there. And so we move our control points from a networking layer up the stack into an application layer, and we start monitoring API calls. So we are using tools like AWS CloudTrail or S3 access logs, S3 bucket policies, all sorts of controls and monitoring to track the API level usage as a boundary protection in lieu of a firewall for just pure traffic monitoring. Serverless. Serverless is an environment that the cloud is not the only way that you can get to a serverless environment, but it is certainly an environment where serverless takes off. They're really married to one another. So in the server world, you have all sorts of precedent for operating system security. The STIG standards, all sorts of NIST controls really focus on an operating system level security. But when you're operating in a serverless environment, you don't have that operating system to STIG. You don't have that operating system to hang your hat on as far as security controls are concerned. And so again, it's another case where we have to move up the stack a little bit, where we're doing static code analysis over the Lambda functions that are being deployed in the cloud. We're monitoring for invocations of those Lambda functions, what their output is as far as a logging level. And most of these don't have one single method that we're able to use or one single COTS solution that's able to say, now we feel we're secure because XYZ's vendor's product has told us that we're good. We have to take a somewhat more complicated and intelligent approach to monitor and identify things that we are worried about, report, and potentially take action if they're of particular severity. And a lot of that's custom code, unfortunately, at the moment. So some of the methods that we use to attack these various challenges: oversight, monitoring. Continuous monitoring is definitely very much a part of what we do. And we're always on the lookout for more efficient ways of doing monitoring or additional items that we can monitor. So again, we are monitoring at a network layer. We're looking for logs from our applications and from our serverless infrastructure, health monitoring things, AWS health reports for the status of their data centers, and unusual behavior where we're using tools like AWS Guard Duty or in our Splunk or Elk environments, trying to identify patterns that are out of the norm. Monitoring's a big part of what we have to do in the cloud. Automation, so we're operating in an environment that has, at the moment, multiple tens of accounts from various different organizations. We anticipate that moving to multiple hundreds over the next several years. And so operating at that scale, we have to use automation as much as we can. if we're setting up basic infrastructure or basic compliance or basic monitoring components, we have to use automation. We have to completely separate ourselves from the decades ago policies of administrators going in and sudoing to something and changing the security parameters in order to meet compliance requirements. Terraform is the tool of choice in our environment for infrastructure as code within the cloud. CloudFormation was used previously and is very AWS specific. We moved to Terraform in order to meet the needs of our growing infrastructure, as well as integrating our Terraform environment to a CI/CD system through Bamboo, and really doing our best to minimize any man-in-the-loop tasks in our infrastructure. And that takes a little bit of balance for us, because sometimes we really do need that man-in-the-loop for approval or some sort of escalation or governance process. We do need someone to have some sort of sign-off on particular changes, but we try to minimize that as much as possible. Self-service. So in our growing ecosystem, our tenants and our applications are growing rapidly, but our internal Earth Data Cloud operations team is not really growing at all. So we have to figure out some way of keeping pace with the increased demand. Patrick is smiling because he's feeling this. So we have to give autonomy to our end users. We have to let them solve their own problems and maintain their own compliance. Otherwise, our internal operations team is just swamped. We can't keep up with that. So an example of that is a year ago, IAM management was held completely within the Earth Data Cloud administration and operations team. IAM is AWS's access control policies. This meant that anytime somebody wanted to make a very sensible, very practical, get everybody excited about change as far as IAM permissions, that had to go through our NGAP operations team. AWS released AWS permissions boundaries, which allowed us for the first time to get the internal confidence that we could delegate IAM permissions to our end user community with guarantees that it wouldn't exceed some high water threshold that we had established for the community. That was a big shift for us, and it enabled an incredible amount of self-service where our operations team was able to sit back and know that our end users both had the ability to solve their own problems and security compliance was maintained through these permissions boundaries. Community is another big part of our effort, which is to not only let our individual developers or application teams solve problems, but the application teams across the entire community to solve problems together. So this is application A has encountered and resolved XYZ problem, working with Lambda or some other AWS service, and we want to make it very easy for them to share that knowledge with other people within the community. So we have various wiki pages and document collaboration and GoToMeetings, and have recently started a kind of open forum office hours virtually. Slack is a big use for our community. This is actually an area of particular interest for me in how we can modernize and advance the sense of community with within our ecosystem to help our development groups be more efficient as a whole. And then customization. Customization ends up being a challenge for us because we do have this large scale with so many organizations and developers and administrators and that we have to manage. Customization means that we have one-offs. One-offs take an inordinate amount of time, even if it's a very small one-off for us. But we do have to allow for it. We do have to allow for a particular priority mission in order to get a new service or a new capability fast-tracked. We have to allow for the business priorities to overrule the desire for us for everything to just be the same. And so we have to develop workflows and methods in order to meet the customization needs of our community. Looking forward, the future is bright for our ecosystem. We just see more. We see more every day. The conversations that we have with our NASA leadership and certainly in the data science community is more that people want to move to the cloud. People want a stable, secure, economical solution for their applications and their missions in the cloud. And we're doing our best to try to keep up with that, which is essentially automate everything we can, even if it's somewhat trivial. That trivial task multiplied by 100 or 200 different accounts becomes overwhelming for us and is just completely unscalable. We have to enable our end users to self-service while meeting our security and budget assurance requirements. And we're starting to look into more intelligent ways of doing monitoring. Right now, our monitoring is fairly data in, data out without a whole lot of added intelligence to it. We're trying to look at ways where we can perhaps like credit card fraud monitoring uses analytics in order to determine whether or not any particular transaction is fraudulent or should be approved. We're looking at ways where we can incorporate some of those same ideas into our budget enforcements rather than just having a specific threshold cap, how we can be more intelligent about this particular activity looks like it should or should not be approved, and balancing that against the tenant autonomy. And near and dear to my heart is continuing to build that that community of support and excellence from our developers. And that's it for me.
Next up is Nathan Clark, who is a software solutions architect for the NASA Earth Data Cloud platform.
Find the right presentation now. So yeah, I work with Ben on the same Earth Data Cloud project where we're managing security and financial controls for a suite of applications and accounts with a lot of different teams building heterogeneous applications. Ben talked a little bit about the financial side of that, the need to not just control our security profile, but also control our billing profile. So I'm going to dig a little bit into what kind of things we're putting in place to help our application owners avoid going over budget. So Ben talked a little bit about the switch from the traditional purchase some servers upfront way of provisioning infrastructure to the pay-as-you-go model. And the fact that this shifts a lot of the responsibility of tracking your costs and understanding what your infrastructure is costing you from a beforehand step that project management and finance and others can get involved in to something that now every individual developer on your team has to think about. The choices a developer is making day to day, the code level changes they're making now have a huge amount of impact on the total cost of your system. And you can no longer just say, well, it's running on the same servers, so as long as I have enough hardware, it's still going to cost me the same. If you're using more memory, you're using more CPU cycles, you're storing more data, you're egressing more data, all of these things dramatically change your cost, and they're things that developers do every day as they're adding features to your system. So the goal is to come up with ways that you can help these teams stick to their budgets, because you do have finite funding to pay for these systems, but without giving up the flexibility that the cloud brings. You don't want to just impose the upfront purchasing model on the users of the cloud in order to get this consistency and these budget constraints back. You want them to be able to re-architect their application because they figured out a better way to do something or a way to get more performance out of it. You want them to be able to do that, even though that is going to change your cost profile on a day-to-day basis. The environment the Earth Data Cloud manages is all AWS, so a lot of the information in this presentation is going to be AWS specific, but I'm going to try to keep some of the concepts generic to other cloud service providers as well. So hopefully some of this is also applicable if you're using or planning to use Google Cloud or Azure or any other provider. The first and probably the most important part of cost control is cost-conscious development. Again, all your developers are now responsible for the total cost of your system. It's not something project management can take care of for them. It's not something that you're going to provide estimates ahead of time and then you don't have to worry about it anymore. Everybody on the development team has to understand the impact that their development decisions are making. From what instance types are you going to use, how many instances, what storage class are you going to use. Instead of just looking at the processing power needed for a certain function, developers have to now start thinking about the cost of that function and how the cost is going to scale up or down based on usage as another factor of their software design. Cost visibility is also dramatically important. Ben talked a little bit about our focus on monitoring. One of the benefits of these cloud service providers charging you for literally everything is that in order to do that, they have to track literally everything. You get incredibly granular and focused low-level detail on exactly what's costing you how much money in the cloud. The kind of level of detail few, if any, on-prem data centers can get. You get the bytes of egress between two different subnets and how many pennies that cost you. You can get to the 4th decimal point costs of specific egress or specific storage that you forgot was even laying around somewhere. And that's fantastic, but it's also a huge amount of data to keep track of. So there's practices to try to roll up certain types of costs into higher level. Well, how much are we spending a month and what's the projected cost at the end of this month? So if that goes too high, you can start digging into, okay, what cost showed up that I didn't know I was going to have. Finally, after all the cost monitoring you do and the cost optimization ahead of time that you do, there's what I call cost controls, which is similar to building in, if you're building software, you'll build resiliency to bad inputs sometimes. You'll build functions that take into account not just the happy path, but certain edge cases. Cost is now an edge case you have to take into account. You need to build functionality into your system specifically to deal with cost and controlling those costs. So digging into the cost control aspect, the kinds of cost controls you can build. There's a few useful patterns that I found in building various types of controls. So again, a cost control is anything you implement, any monitoring or automated action that you build into your system that's intended to help keep you from going over budget. It's useful to categorize these into either internal or external, or proactive versus reactive. And I'll explain what each of those axes mean. For internal versus external, you have your AWS account or your cloud environment. You're provisioning a bunch of infrastructure in that environment, EC2 instances, Lambda functions, buckets full of data, whatever your system contains in the cloud that you're paying for. You have a development team that's actually responsible for that infrastructure, that's deciding what you're provisioning. Those are your internal costs. These are your team making decisions where you can look at AWS's pricing model up front and say, okay, how much is this going to cost me? How much does this instance type cost per hour? How much does this data cost per gigabyte? On the other side, you have end users, or you could have external systems, whatever is hitting your system from the outside that you don't have direct control over. You don't know how much traffic they're going to hit you with. You don't know how many requests they're going to send you or how much data they're going to download ahead of time. These are the externally imposed costs. Some of the costs are kind of hybrid. You might provision an auto-scaling group of instances that scales up and down based on demand. You internally provisioned the auto-scaling group, decided what instance type it's spinning up and how big it can get, but it's usage that drives how big that group gets. So you can predict the peak usage cost. You can't necessarily predict how much of the time your system's going to spend at that peak usage, or if you've actually provisioned that peak high enough. Maybe you'll get twice as many users as your system can actually handle. The other side, proactive versus reactive controls. Proactive controls are the ones that are always on, the things you build ahead of time to help keep spikes from happening, or to at least let you know, hey, a spike is happening. Reactive controls are what you do when it happens. A spike occurs, you run a Lambda function that stops instances, removes somebody's access because they've got a malformed script, things like that. It's reacting to the events that are driving cost. You can't rely on one or the other. Proactive controls are generally better because they can stop bad events from happening, but sooner or later, something's going to get past that and you're going to have to react to costs going higher than you wanted, or a usage spike that you just can't afford. Some of the kinds of reactive actions you can take, and Ben talked about a couple of them, like the freeze spend or the circuit breaker, range in severity. If you have a fairly low budget threshold, like you're at 80% of your budget, but you still have some wiggle room in there, maybe you just slow down access, add a rate limit to some of your APIs, deny access to some S3 buckets that are really just ancillary data. They're not primary. It doesn't really matter if people lose access to that temporarily. Other actions are more severe. Maybe you have to actually block all access to your system, take the entire thing down for end users, because if you completely run out of money, now you're to the point of actually having to delete data. And it's better to have the system down than to actually permanently lose data. And you're having to choose between, do I deny access to end users, or do I have an even worse after effect of having run out of money? I've got a few examples of the kinds of controls we've built on the Earth Data Cloud. And it's important to recognize here, since we're managing a ecosystem for other application owners for a very heterogeneous set of applications, the kinds of controls we've built are deliberately fairly generic. They're controls that we can put in place for all of the accounts we manage. They're not specific to individual applications. If you're building a specific system, a specific data processing pipeline, there will be more powerful but more focused and specific controls that you can build based on understanding what data is important to your system, what instances are safe to stop, what data is safe to move to Glacier, what endpoints are safe to cut off, in a way that we can't do as easily generically, because we have to just have a rule for all instances, all S3 buckets, and so on. We can't manage the number of exceptions that application-specific logic would need. But it's important to have that application-specific logic as well. Don't just rely on generic guardrails that you could apply to any system, but think about where your application incurs costs and what the main cost drivers are based on the usage of your application to figure out where to target additional cost controls. So the number one control you want to have in place is budgets and alerts. You want to be tracking how much money you're spending and on what. The simplest alert to start with is, how much money do you think you're going to spend? Set an alert for $1 higher than that. You are guaranteed to miss some of the costs, some of the little granular details that cloud service providers charge you for that you didn't realize they were going to charge you for. The best way to find that is through experience. Run the system, set an alert for spending more than you think, and when you do, because you inevitably will, that's when you dig down and try to figure out, where is this extra cost coming from? Where's the line item that I didn't know AWS was going to charge me for? And as you do that, you can iterate on these alerts and figure out, okay, now I have a better estimate. I have better metrics on how much the system's going to be used. I can figure out a better range to set this alert for. So I'm not just getting a bunch of alert spam. I'm actually getting meaningful information that tells me, okay, something happened that I didn't expect, and I need to add that to my cost model. The second piece, Ben referred to this as well. AWS specifically comes with some built-in soft limits. Things like you can only run a certain number of EC2 instances of a certain type. You can only create a certain number of buckets. These are useful mainly to help you not accidentally cost yourself too much money, to prevent accidentally adding an extra 0 when you spin up a cluster of EC2 instances. The downside is they are often focused more on maintaining the health of AWS itself than on keeping your costs down. There's often soft limits on things that are just rate limits on an API that doesn't really cost you that much, and then no soft limit on something like how much data is in this S3 bucket, which can cost you an immense amount of money. That's where custom soft limits come in. You're not limited to the soft limits that AWS builds in. You can create through custom code or through IAM policies your own soft limits. You can stop people from using regions that they shouldn't be using so they don't accidentally spend a lot of money transferring data across regions because they didn't realize the console just decided to default to a different region than they thought they were in. You can add limits on what instance types people are able to run so they don't pick one that costs orders of magnitude more than the one they thought they should pick. The thing that makes these soft limits soft is that there's always exceptions. There's always going to be somebody who does actually need that feature. They really do need that R4.32 extra large that costs $20 an hour. And they should have a way of raising the soft limit. They should be able to ask you, hey, I do need this. Can you remove the soft limit from my account? This is where human processes come in. Some requests like that, you may need to escalate to whoever does actually hold your budget. Somebody's got to sign a piece of paper saying this is how much money you have. There's points at which development changes escalate to the level of needing their involvement. Talk about the free spend and the circuit breaker briefly. Ben did refer to those for a bit. These are two different levels of starting to shut things down because you've hit a budget limit. These are the kinds of reactive controls you would run when you haven't hit the amount of money you have to spend, but you're getting close to it and you might need to start providing a reduced level of service to avoid going over budget. The free spend doesn't stop anything that's currently running, but it stops people from provisioning any new things. Your development team can't spin up any more instances. You can't add any new S3 buckets. You may also choose to start limiting or stopping data from being added to S3, depending on what kind of system you're running and if that's required for end users to still have access to the system. The goal here is your app is still up, you are still available to end users, but whatever's happening that's causing your costs to scale up to the point that you are going to go over budget if it's continued, you've hopefully slowed that down. You've stopped whatever action was steadily increasing your hour by hour costs. The circuit breaker is the next level of escalation. This is, you're at like 95, 99% of your budget, and you really need to start shutting stuff down. This is stopping EC2 instances, cutting off load balancers, cutting off access to S3. This is actually taking your system down, but without permanently deleting anything you can't possibly recover. This is the point at which you're deciding, I need to stop serving this service up to the users because the alternative is I run out of money and I have to shut this whole project down. The goal is to never hit this by putting the other proactive controls and monitoring and better budget and cost modeling processes in place. The final control, and this is really more of a family of controls, is controlling egress. This is data exiting your system, which again, cloud service providers are good at charging you for literally everything you do, and that includes every byte of data that exits the system and goes out to end users. This is another control that, because it's imposed by the users of your system, you don't have very good control of. All estimates are wrong to some degree. Your estimates of egress are likely to be the most wrong. That's really why there's, on my project, a large focus on controlling egress. It's not our biggest cost. Storage and processing costs tend to dominate project budgets, but those are more predictable. Those are things that projects can decide. They know how much data they have. They know what they're going to do to process it. their estimates and the budgets they come up with based on that are going to be relatively accurate compared to Egress, which in many cases is just a educated guess about how popular a data set's going to be. So it's not the biggest cost, but it's one of the harder costs to control and the harder costs to predict. Whenever you're evaluating what cost controls you need to put in place and what needs to be prioritized, the two things that are important to look at are, one, what is the biggest cost? Obviously, you want to save money there. And the second is, what are the uncontrollable costs, the unpredictable costs? Because they could become the biggest, and you want to already have the control in place if that happens. So what we call egress, basically any data leaving your system that costs you money. There's plenty of ways to egress data. Focusing on AWS, some of the primary ones we see in our system are data leaving EC2 or your VPC. This is, you're running something that looks more like a traditional application, and those bytes are transmitted out to end users from a load balancer or directly from an instance, and you pay for that. The other side is S3, where you're hosting data on S3 and providing end users direct access to that. There's an option of putting CloudFront in front of either of these things. CloudFront is a caching CDN. Caching can get better performance for users, but specifically with regards to cost control, CloudFront is nice because it's cheaper for a gigabyte of egress. You can put CloudFront in front of S3 even without caching enabled, and you will pay less for the total egress out to the internet. This gets more complicated because there's lots of different price classes based not just on what service you're using to egress the data, but where the data is going. If you get data from EC2 or S3 to the same region, that's largely free. In S3, you pay per request, but you don't pay for the gigabytes of egress if it's not leaving the region. If you're going from from one region to a nearby region, US East 1 to US East 2, for example, that does cost you, but it costs you a similar amount as just having data across two different subnets in the same VPC can cost you. If you go to a region that's the opposite side of the continent or another continent, that's going to start costing you a lot more. And the most expensive cost is when your data is just going out to end users on the internet who are not actually making use of the same cloud service provider. Which of those is cheaper might differ based on the service. You might want to choose between giving people direct access to S3 versus pushing that download through CloudFront based on where they're coming from. If they're in the same region, you want them to download from S3 because that's going to be free. Whereas if you push them from CloudFront, even if they were in the same region, you'd be paying for it. If they're not in the same region, CloudFront's a good idea because you're going to be paying less. But that might depend on whether they're coming from a close region or not. So you end up with some fairly complex logic to decide what is the most cost-effective download mechanism based on where the data is and based on where the end user is. Those will be, the answer to that is going to differ based on the size of your data and based on your cloud service provider, obviously. Many of these services provide tiered pricing where the first N gigabytes of data cost you a certain amount, but then as your storage quantities and total quantities of egress go up, the rates get lower and lower. So based on your prediction of how much data is going to egress, you might have to make a different decision as to what download mechanism are you going to provide to end users. On the Earth Data Cloud, we are using the Lambda at Edge feature of CloudFront to help with our decision-making logic. This effectively lets you add logic out at the edge, at the CloudFront layer, that can alter responses or even decide to serve up the data from a different place. So we are tracking at this layer, where is this user, where's the data they're going to download, and based on how much data has egressed so far in the current month, what download mechanism are we going to give them? We can give people unthrottled data access for a while, but then when a certain budget threshold is hit, switch everybody to a throttled level of access that slows down everybody's downloads, decreases the total quality of service, in order to keep us from hitting the more severe controls like the circuit breaker and others. There's a few different ways to implement this logic. Ben talked a little bit about the different layers of protection, since you no longer have a single like network pipe into and out of your system. That applies here as well. If you're providing access to something running in your VPC, you have security groups and network ACLs where you can restrict things by IP. So you could say this can only be directly accessed by people who are in the same AWS region. AWS does publish all of its IP ranges, so you can create restrictions like that. So you could actually have a different endpoint available to people who are in the same region versus outside the same region to assure that people are always using the cheapest possible mechanism to get to their data. Like I mentioned, we're currently using Lambda at Edge to handle a lot of our decision-making logic. There's also logic you can put in IAM policies or S3 bucket policies to do similar things. Where is the user coming from? Given this, should I give them this kind of access to the data, or do I need to give them a different kind of access? Ways you can slow down people's access to data. First, obviously you need to monitor it. You can't do anything with egress unless you're tracking the amount of egress that's going out. This is hard in the cloud because, again, there's no longer just one place that the egress is happening. You have to track access logs from n different services plus egress rates from VPCs and collect that into a tool that gives you aggregated views of all of this. Once you are tracking the egress, once you have a way of recognizing this application has egressed X many bytes in total across all of the different ways it gets data out, and you decide, okay, now I'm going to slow this down, you have a couple different ways of doing that. One is the brute force, just start rejecting certain requests. This is rate limiting how many requests per second they can push in, returning a 429 or a similar error response if they're hitting a rate limit. That lets clients know, okay, you need to slow down. The downside of this is whatever is hitting your data set needs to know how to respond to that. If this is a person, they might just hit the refresh button in their browser, and that's fine. If this is a script or an Esri plugin, it's a little more mixed whether it's going to respond to a 429 properly and try incremental backoff or other mechanisms to try to get to that data later. This is where the approach of actually limiting the download bandwidth comes in. This means that every connection still succeeds, but it might not get the full bandwidth available to AWS. This requires actually having some kind of proxy, some network layer appliance that you control in between the user and where they're getting the data from. In order to have this kind of bandwidth limiting, you can't give the users direct access to S3 anymore. You actually have to have something in between the users and S3 to set this is how much bandwidth they're actually going to get. This is expensive. You're running a network appliance effectively, and you have to pay for that appliance runtime. You have to pay more for the data that passes through it. So the trade-off here is you are paying more per gigabyte of egress in order to get more control and more predictability over how much exactly is going to egress. This is where you get back into knowing your application. For what you're doing, keeping costs down might be more important to you than keeping the application up. You have to measure the severity of, would it be worse for me to make my egress cost twice as much, or to have to take my system completely down at the end of the month because I'm out of money? The decision might be different from system to system. You might have one system that you're willing to pay more per byte of egress in order to get the level of control that bandwidth limiting gets you. You may have other applications where you would rather make it cost less with the risk that at the end of the month, the circuit breaker gets invoked because you ran out of money. As far as actually implementing a bandwidth throttle, there's several ways you can do that. When you're proxying data through EC2, every EC2 instance has an intrinsic network limit. There's only a certain number of bytes it's going to get in and out. Depending on the instance type you're using, that may be a documented, this instance type gets 10 megabits per second. It may be a more undocumented, it's slow. And sometimes you get a burst of faster bandwidth. So there is a cap. You may not have as great predictability of that using just the instance type. You can add on top of EC2 network layer or kernel layer network limiting using tools like traffic control to say only allow this many bytes per second out of the networking stack. It does that by buffering packets and just not sending them out through the networking stack based on various algorithms that you can configure. You can also handle application layer throttling, either in like Nginx or Apache or whatever your application is sitting behind, to only allow a certain number of requests per second, connections per client, things like that. So there are several layers where you can implement bandwidth limiting in order to slow your users down rather than cutting them off entirely. The final decision is whether you want to build a bandwidth limit that's completely custom, which might make sense if you're building a single application or a single system, versus buying a tool, a COTS product, a virtual appliance that can perform this kind of function. The tools that do this are really expensive, but they also do this for entire suites and families of applications rather than just one. So if you have one or a small handful of applications, doing it custom might make sense from a perspective of you'd rather spend the development time doing that than the relatively large amount of money it would cost to buy a product that does it for you. If you have a much larger number of applications and they're very heterogeneous, they're not all just serving data from S3, they're doing a variety of things, and you want a tool that can handle bandwidth limiting for all of them, this is where it's potentially worth looking into off-the-shelf products that perform this, but at a cost. It's an example of the kind of decision-making logic we are implementing on the Earth Data Cloud platform, where we can provide either direct access to a data set in S3 for users that are in the same region, access to a application potentially hosted in EC2 for users that are in the same cloud but in a different region, or access through CloudFront for the lowest per gigabyte cost for users that are completely outside the cloud. This is a simplification. We have some more decision-making logic in here based on, well, are they at 80% of their budget, then do this, things like that. That's kind of an illustration of the kind of logic you want to put in place in terms of determining how you're going to let users download this data, whether or not you are. So that's basically the end. Again, the choice you're making through cost controls is you always have a risk of either running out of money or running out of capacity. You could put a cap on how much data can egress or how many EC2 instances can run, and your risk is you have more usage and people get cut off or people get slowed down. The alternative is you have a much higher cap. You let your EC2 instance, your auto scaling groups scale up as much as is needed to serve the traffic. You don't put any limits on egress. And now what you're running out of is money. You're going to get a bill you can't afford at the end of the month. The key is, again, cost is now one of the factors you have to optimize and design around when building software in the cloud. Just like you don't design only for the happy path when you're writing a function or a library, you have to build cost consciousness into your application now in order to keep from getting a bill you can't pay at the end of the month. And that's all I've got. Got some links in here to AWS cost management white papers and some of the other things I referred to in the presentation. That's all.
All right, so we have time for some questions if anyone has any.
Testing. Okay.
Hi there. Thank you for the presentations. It certainly opened up a whole field, and you described some of the anxiety with cloud migration and coming from a government agency, you know, that there is, and especially on the costing, having developers think about cost. I mean, that is a big shift for us. I don't necessarily want developers to think about cost. So how do you enable that quantification of what the cost is or what they're developing? I want them to innovate. I don't want them to be thinking about budgets. And yet there's this reality that you're going to pay after the fact, you know, for what's happening. So that's the one question. What tools are there, and how do you empower developers to make that assessment of what they're developing? And then a second question, if I may, what's the budgeting infrastructure? It seems just on the cloud budgeting, you have a whole new infrastructure you have to stand up to keep track of all this, not just software, but on manpower as well. So thank you very much.
Try to answer the developer empowerment piece. If you have developers implementing new features, sometimes they will, you know, build a thing that solves the problem correctly, but in a way that is either going to be complex to maintain or it's inefficient. These are things that software development has always suffered from, and you have approaches like code reviews. That's a big one for helping to deal with, like, yes, you solved the problem correctly, but hey, you should think about this thing you haven't thought of. It's a way of educating all the developers on the team to think about the maintainability of the platform. What about, I think there's an edge case here you missed that's going to cause an error in this function you built. Cost is now one of those things you have to bring up in peer reviews. If somebody builds a feature into the system and they're using a certain AWS service that somebody else on the review realizes, you know, that charges per request and you're having this called 8 times each time the Lambda function is invoked, it's another thing you bring up in code reviews, and you help through that mechanism kind of teach the whole development team, just like you would teach them to think about the maintainability of the code, and making sure you have unit tests and things like that. It's another piece that you deal with as part of the ongoing peer review and code review process as you're building the software.
So I think it's, for me, like working in this environment, I think it's less of a thought. I think less about the but, more about just efficiency and quality overall of the code. Ultimately, I'm not concerned about what the actual budget is. I'm just attempting to ensure that my code is running as efficiently as possible, right? So if I have a loop that's running through a new service 8 times, can I do that more efficiently? And I, you know, generally speaking, you would probably say yes. Can I send that as a bulk request? Will it save, you know, processing power? And that's ultimately just a kind of a sign of quality versus a budget concern.
And I'll add on to the cost optimization and getting our developers on board with that. Developers are tinkerers, and they want to solve any problem that's presented to them oftentimes. So in addition to the peer reviews and the visibility from the team perspective, we also expose and push cost information to our developers. So it's always something that they are seeing at various different levels. Their login to our cloud ecosystem on the one side says enter your credential information, on the other side says this is how much your account has costed in the last several weeks. So they are seeing that every time they come to the cloud. They're seeing our environment is starting to get close to a budget threshold, and they need to start looking at that. Additionally, in the traditional IT procurement world, I know that working in data centers, I never knew how much the servers cost. I never knew how much the racks cost or how much the switches cost. And there was no place that I could go to even find out that information. In the cloud, in AWS, all of that information is made available to our end users. So they have access to and seeing this information. And just from the nature of most of the developers that we work with, their curiosity and their desire to tinker with things, we find that it's somewhat self-correcting in as much as they want to get the next ounce of horsepower out of their application while reducing that cost. And we find that helps them, pushing that information to them.
That seems to align well with the thoughts that you put on the screen about having lots of different communication mechanisms to socialize that information across the ecosystem.
Absolutely. I think there's a question in the back.
It's for the people online.
I know, but thanks. Okay, so just an observation and a question, and maybe there'll be data that we will find out as this process becomes more. Any paradigm shift, because we've all gone through several in terms of what kind of infrastructure, computational infrastructure we use, and whose responsibility, accountability is it, and how they use it. So, you know, we talk about doing science in the cloud and how easy we want to make it for whether it's a scientist as the developer or a developer that's doing software tools. And so it will be interesting as we go forward if we are really coming up with sort of probably not a good term, but a cloud application engineer kind of thing, because we've got sort of the, you know, you guys that really know how to sort of help us use the cloud and what all, not just to get the data, but to actually do work, so to speak. And then we've got a developer level down here that, you know, they don't want to have to try to engineer or design how best to use this. So in the, a lot of times when we write proposals, we've put in money for a server, as you all mentioned. You know, now those costs may not be for that piece of hardware, but it's going to have to be put into the resources of either cloud cost and or some more labor costs to help us sort of go through this whole semi-layered operation. So anyway, let us know what you find out.
Yeah, so I think one thing I'd like to address is the idea that there is like a cloud software engineer versus a regular software engineer. And I think you saw that paradigm early when people were moving to the cloud. But the risk there is you end up with this like layer of gatekeepers. And so I think the most successful organizations that are using the cloud, it's really an education level for all of the software engineers. So sure, a software engineer like might not be interested in certain configurations of AWS. They just want this thing to work, but you have to give them the support to learn that themselves. Otherwise, you just create a big bottleneck with this different labor category.
Hey, Sky Bristol with USGS. Thank you all very much. You guys are very knowledgeable in this whole field. I have 3 questions for you. One, I don't see kind of happening at the technical level across agencies much communication and collaboration across groups like yours who are doing this sort of thing. I come from the Department of Interior. We have a very different sort of platform there, a lot of other kinds of constraints, but we're all dealing with exactly the same problems, of course, as we try to move this ahead. So what forum exists, or what forums are you trying to tap into maybe to help spread the knowledge and spread communication across the different groups that are working in this space, particularly here at ESIP and beyond? So that's one question. Other 2 kind of technical questions. There was one note about kind of trying to help avoid the practical vendor lock-in that comes here. It's sort of the nature of the beast. There are so many of these specialized services on AWS and Azure that, you know, you kind of got to drink the Kool-Aid and learn how to do things in that world, and then you can spin stuff up. What are you guys working on to mitigate that, though, in terms of how the code bases are managed, how the development process is engineered, to help kind of move beyond one particular vendor space as you need to deploy onto something else? Last kind of technical question has to do with cost controls. Everything you talked about here mostly is still dealing with the user as an anonymous user base, maybe looking a little bit at the region that they're coming at from, but not looking at any kind of QoS throttling or management for polite user bases or known user bases based on API key mechanisms or those kinds of things. Are you doing anything in that space, and particularly dealing with some of the privacy issues and whatnot that we have to deal with in government in particular for dealing with those things? So sorry if those are big loaded questions, but those are the ones that occurred to me here. Thanks.
All right. For the first question, which I believe was about communication and helping spread the knowledge across government agencies, we have a problem even within the division of NASA we work for, where there are several teams working on different missions, and they end up in silos where they're not talking to each other as much. So we've seen huge progress just in now having a single kind of cloud ecosystem that a lot of these different missions, a lot of these different groups are sharing. We're starting to see a lot more communication between these groups where they're helping each other solve problems because there's now a shared platform and shared communication mechanisms for all the people who are using the Earth Data Cloud platform. As far as getting that kind of information out beyond just the people who use Earth Data Cloud, at this point, we're really basically here at ESIP and certain other conferences having talks like this is the level at which it's gotten. It's a big problem trying to share this knowledge across more and more people, but it's also sometimes hard to get through the organizational specific silos. We work for one specific part of NASA that has a specific way of doing finance and budgets and proposals. And a lot of what we do is kind of built around how they manage budgets and doesn't translate as easily potentially outside our system. But there is information like what we shared today that can hopefully help others, even if they're not in the Earth Data Cloud or don't work for NASA.
I have just one thing about the vendor lock-in question you had. I think this is, especially when you initially try to move an organization to the cloud, by far this is the largest concern. I have two thoughts on it. The first is that you can absolutely interact with the cloud at an abstraction level, where you can pick up and move to Google, or you can pick up to move to Azure. In fact, when people move to Terraform, this is often like a selling point they'll say is like, oh, well, Terraform can be generic. What you'll find is while it's true, it makes it easier to move, you lose like almost all of the meaningful advantages of picking a cloud vendor. It's like back in the days of Oracle, right? If you have an Oracle database and you choose not to use any of those features, it's like, yeah, you can then pick up and use another database, but you're not really getting the advantage that you're paying for. And then the second thing is that the real lock-in, in my opinion, is not the services you use within the cloud, it's where your data is sitting. And so especially when you talk about like the several petabytes of data that sit in a cloud vendor, that's what's going to bottleneck cost-wise of moving to another cloud. So like, yeah, you can decouple yourself from a service, but if you've invested all of your organization's data already into that cloud service provider, that's got to be your focus.
Yeah, could you remind us what the third question was?
Bill,
It's not something we're doing today. It's on the roadmap. The place we're looking at it now is similar to how we're deciding, like checking what region you're in based in CloudFront. There's options we have to start actually doing a basic level of user authentication, starting with things like, well, let's throttle a specific source IP because this one IP is hitting us. But then levels above that, can we actually authenticate this user? We know who they are, we know who they're associated with. They're going to continue to get unthrottled access, even though everyone else is currently throttled. It's not something we're doing yet, but it's something we're actively discussing and hoping to start rolling out.
I know that the JPL PODAC has authentication for using certain download facilities. Are you thinking of implementing something like that?
Thinking, yes. I don't have a lot solid beyond the fact that it's percolating still.
So kind of a logical extension to that, that I have heard some murmurs about is that once you start getting into this mode of you have like your QoS layer that is, throttling certain users, there is this slippery slope towards what impacts that has on the concept of free and open data and those sorts of things where when you know down to the penny how much it costs you to egress data outside the United States, and someone sends that email to their congressperson or whatnot. Like, what is the natural result of those things? And I think those are, let's say, challenges for the future that this community is probably going to have to deal with.
I think we heard some of that discussion at the NOAA EDM workshop. There was a speech by Neil Jacobs who brought up some of those exact questions. And I know from the scientific side, the reaction was not very good.
Just for clarification, I didn't introduce myself. Eugene Berger, and from Pacific Marine Environmental Lab in Seattle, one of the NOAA labs. So is the NASA system in the same FISMA boundary? This stuff that you described today, this cloud implementation, I see there was a logo, I'm not sure. Is this one system and is it in one FISMA boundary? And the second question, can you comment on the TICAP restrictions within the federal government? Is that still a restriction? I heard there was going to be some relaxation on that. I'm not sure if it happened. And that the impact to your cloud implementation. Thank you.
So the TIC is still very much an in-progress thing. There's a draft memo, I believe, indicating that the initial requirement that everything has to go through a TIC no longer exists, but exactly what's going to replace it and what those requirements are is still not entirely clear. It does seem to be fairly clear at the DHS level that this controlling everything at the perimeter, controlling everything through one network pipe no longer works, and that we do need a more defense in depth kind of approach, a distributed mechanism to track everything coming in and out of the system when there's no longer one endpoint that it goes through.
Looks like we had a question.
Trusted internet connection. It's a DHS level mandate. Yeah. Yeah.
So NGAP is one system, GCC is another. NGAP is a collection of dozens, maybe more, AWS accounts. They're FISMA moderate. GCC is FISMA high. It's the same model, but we have a tighter security model because we have mission networks and other data.
Hi, I'm Namrata from JPL. So my question is, we get requests from scientists based to produce certain products based on their areas of interest, but all of this production is happening on the same cluster. So it's not dedicated infrastructure or resources per request. So how would you deal with billing across multiple accounts for a set of resources, and how would you avoid accidentally charging someone else?
So we had initially did a lot of billing based on tags in AWS where different resources were tagged differently, and we found that got unmanageable quickly. So what we're currently using is a account-based approach where every different project, anything that has a different funding stream, actually needs to be resident in a different AWS account. When you get shared resources, like a shared service that a lot of different accounts are using or a lot of different projects are using, the first task is to just start tracking that data. You need to know what drives the costs for that service, and you need to be tracking that request by request. How many of these requests, how much of the workload is coming from where? Because it's only once you at least have that data, whether this is from access logs or API logs or something else that the shared service provides, that you can then figure out, okay, given that the account where the shared resources are running cost $1,000 this last month, what percentage of that was really incurred by what set of users?
Right. So I think we started using, we do use auto-scaling groups, but we had dedicated auto-scaling groups depending on the request, and we tagged them. But how would you distribute the charge when it comes to storage? Because it's not dedicated directories or paths per user. It's a production system, so the organization of the objects are different. They're not account-based.
Sure.
Certainly difficult to give the answer that you should run with given the variances in different applications or usage patterns. But we have a similar problem in our environment for how we distribute the cost of monitoring tools, some of which are resident in a particular account, and we can say, hey, there's a slice of overhead that's in your AWS account that you're just consuming. Some is in our management accounts that end users don't have access to. And that's an area where we have started with, hey, we think that a blanket overhead sort of percentage will cover things. And as we're moving forward, we're trying to get more precise about the apportionment of that overhead based on usage. And so to Nathan's point of really identifying what the increments of usage that people should be charged for and incorporating that at some sort of apportioned amount to that S3 storage total. Say, well, you made 1,000 requests, your neighbor made 3,000 requests, you're going to get charged less for that overhead storage. Is basically how we're doing it today. If that's any help.
All right, so we are bumping up against the end of this session and lunchtime. So I think we'll call it here. If you have any further questions, you can ambush these guys at lunch. Thank you all.